In our last lesson, we talked about, or we learned how to draw Lewis structures, and we learned how to represent both ionic compounds and molecular compounds. And that is important because a lot of how a compound behaves has to do with its actual structure. Today we need to talk about something else that determines how a compound behaves, and that is polar bonds. So some bonds are not exclusively ionic or covalent. This is because in molecular compounds between two different elements, the electrons are not shared equally. And this is because one atom has a higher electronegativity. Remembering that the electronegativity is an atom's ability to attract electrons. So in this compound, one of the atoms has a stronger attraction to the electrons. So what happens is they actually spend more time, or they're pulled closer to the atom that has the higher electronegativity. So the atom with the higher electronegativity pulls the electrons closer to itself. Okay, so we're going to take a look at an example using hydrochloric acid, but before we do that, we have to learn where to find our electronegativity values. To find the electronegativity value, you need to look on your periodic table on the side that says Alchem periodic table of elements. At the very top there's kind of a little bit of a legend showing the box for hydrogen, and if you look really carefully, you can see that right here that there's a value 2.1 that belongs to electronegativity. So everywhere on the periodic table, in every box, right below the atomic mass is the electronegativity value for that element. Going back to our example, we need to find our electronegativity values for both hydrogen and chlorine. So looking at your periodic table, your electronegativity value for hydrogen right here is 2.1, and the electronegativity value for chlorine right here is 3.0. So because chlorine has the higher electronegativity value, the electrons are pulled more strongly towards the chlorine atom. Because those electrons are negatively charged and they're spending more time in one area, it means that the area they're spending their time in has a slightly negative charge. When electrons are pulled towards one atom, it results in partial charges. So when we draw or represent a bond where the electrons are pulled towards an atom, we draw our structural diagram like this, and then we use a symbol like this to indicate our partial charge. So hydrogen gets our symbol and a positive sign, and chlorine gets our symbol and a negative sign. And if you need to make yourself a little note here, you can to say that it means partial. So partial is shown in blue. Okay, so make sure you've got this down before I move on. So the reason we look at electronegativities is because we can use the difference in electronegativity to predict what type of bond they're going to form. So that's called looking at the electronegativity difference. And the electronegativity difference is basically calculated by subtracting the electronegativity values of the two atoms. So we look at our example of HCl. Chlorine had the electronegativity difference or value of 3. Hydrogen had the value of 2.1. So our electronegativity difference equals 3.0 subtract 2.1. And that's easy enough to do in our head. We get 0.9. Once you have your electronegativity difference between two atoms, you can look at the electronegativity scale, which looks exactly like this. If your electronegativity difference is between 0 and 0.4, you have a nonpolar covalent bond, which means the electrons are shared equally. And because they're shared equally, it's actually a weak bond. So it looks a little bit like this, because if you think about the nucleuses of the atoms being these two dots here and here, the space that the electrons are filling is all this area in here. It's an equal distribution. There's an equal chance the electrons is in any of this space. If your electronegativity difference is between 0.4 and 0.7, you have a polar covalent bond. This is when you have that unequal sharing of electrons. Because there's an atom with a higher electronegativity value that is pulling the electrons towards it really strongly, the bond is actually quite a bit stronger than a nonpolar covalent bond. And if you were to draw what it kind of looks like, you have one atom here sorry, it looks a little bit like this, because one of the atoms, remember the nucleus is here, has a very large electron cloud, a very large space where the electrons are, because the electrons are more in that area, whereas the other atom right here is a much smaller electron space, because the electrons are not spending nearly as much time near that atom. Finally, if your electronegativity difference is greater than 0.7, you have an ionic bond, and that the electrons are transferred from the metal to the nonmetal. And because they're transferred, the bond is very, very strong. So the important thing to remember from this lesson is that a covalent bond can either be nonpolar or polar. So depending on the difference in electronegativity between the atoms involved in the bond, you will either have an equal sharing of electrons or an unequal sharing of electrons. And whether or not you have polar bonds makes a huge difference in terms of how the molecule interacts and behaves chemically, which we're going to learn about in the next few lessons. So before you turn this off, make sure you have this page paused and copied, and your practice will be assigned in class.